A slider in a machine moves along a fixed straight road. Suppose x is the distance along road and t is the time. From the table given below, find velocity and acceleration of the slider at time t equals 0.3 seconds. We wish to find out velocity and acceleration of the slider at t equals 0.3. That is, we wish to interpolate at t equals 0.3. We have t equals 0.3 is located towards the middle of the tabular data, and hence we can make use of central difference interpolation formula or Stirling's interpolation formula. Here, making use of Stirling's interpolation formula will give you interpolating polynomial for distance. Since we are looking for velocity and acceleration of the slider, we will have to make use of derivative formula of Stirling's interpolation formula. First derivative of Stirling's interpolation formula will give us velocity of the slider, and second derivative of Stirling's interpolation formula, which is the derivative of first derivative, will give us acceleration of the slider. Here we have h equals distance between consecutive t values, which is 0.1. We have origin t0 equals 0.3. Since we have shifted origin towards the middle, we have a plus nh equals 0.3, and thus giving a equals 0.3 and h equals 0.1, we have nh equals 0, from where we have n equals 0 since h is non-zero. Now we have a special case n equals 0. Thus we can make use of standard derivative formulas of Stirling's interpolation formula given by f dash of a equals 1 by h delta y0 plus delta y minus 1 divided by 2 minus delta cube y minus 1 plus delta cube y minus 2 divided by 12 plus delta raised to 5 y minus 2 plus delta raised to 5 y minus 3 divided by 60 minus etc. We have f double dash of a equals 1 by h square delta square y minus 1 minus delta raised to 4 y minus 2 divided by 12 plus delta raised to 6 y minus 3 divided by 90 minus etc. At n equals 0. We draw the central difference table. First difference column values will be difference between consecutive values given in the preceding column. Similarly, second difference column values will be difference between consecutive values in the previous column. Since we have taken t0 equals 0.3, this value will be t0 minus h, this value will be t0 minus 2h, this value will be t0 minus 3h. Below t0 we will have t0 plus h, t0 plus 2h and t0 plus 3h. Correspondingly we have notations. This value will be y suffix minus 3, this value will be y suffix minus 2, this value will be y suffix minus 1. Here it will be y0, this will be y1, this will be y2 and this will be y3. We have first difference column will have notations delta y minus 3, which equals y minus 2 minus y minus 3. Delta y minus 2 will be difference between y minus 1 minus y minus 2 and so on. In the second difference column we have delta square y minus 3 will be delta y minus 2 minus delta y minus 3. In the third difference column we have delta cube y minus 3 equals delta square y minus 2 minus delta square y minus 3. Similarly, we have the other differences also evaluated. While using first derivative formula, we will be making use of these two values and these two values as well as these two values. Notice that while using central difference interpolation, our required set of values will be located towards middle of the difference table. When you use first derivative formula, first difference, third difference and fifth difference column values are used, which are centrally located. When we use second order derivative formula of Stirling's interpolation formula, we will make use of centrally located values from second difference column, fourth difference column and sixth difference column. Thus we have, giving the particular values in the standard formula, f dash of t0 equals 5.34 centimeter per second and f double dash of t0 equals minus 45.6 centimeter per second square. This is the velocity of the slider and this is the acceleration of the slider.